Well, let's bring in Russell Hill, CEO of Solidia Technologies, joining us from San Antonio, Texas. Good to have you, Russell. It's interesting what you've got on your plate there. This production of cement, we know, of course, is the world's largest, second largest emitter when it comes to carbon dioxide. You found a way to decarbonize that by changing the chemistry of cement. Am I correct?
That's correct, Christine. And yes, it's what's unique about the Solidia technology, and we're not manufacturing, we're actually a technology transfer. We're hoping to provide solutions to an industry that's in dire need of solutions, is really both how we are similar to the traditional cement and how we differ. So how we're similar is we're using the standard components, the standard manufacturing process, but what we've done is just change the recipe, the proportions. So a large part of the carbon footprint of the traditional cement is related to the constituents. So there's a CO2 evolve when certain constituents dissolve and emit CO2. And then there's also the very high temperatures, processing temperatures that are used to produce the cement. In our process, because we've reduced the culprit that emits CO2, we've reduced the CO2 emission by 30%, and then we are changing the firing process to a much lower temperature. So overall, there's about a 30% reduction in CO2 during the production, and then the resulting product actually binds CO2 in making in going through the hardening process.
Okay, I'm not an expert, but it sounds to me that it's a technology that hinges on you trying to capture that carbon. What's the best way to find that carbon for you to actually transform it?
Yeah, well, surprisingly, with all of our discussion around, CO2 emissions and how to reduce emissions, that can actually be the challenge. Similar to many other, emerging technologies, the infrastructure is often lacking. So, when we're looking today for CO2 to combine with our product to produce our cement, we're competing often with beverages or carbonated other materials at a very high cost. As the technology further develops and there's more access to CO2 that's traditionally being sequestered or put into the ground now or just going out into the atmosphere, we hope to be able to bind that into making viable products that have commercial value.
This carbon capture technology, can you extend that? Can you extend it to other building materials?
Today, it's primarily focused on cement and concrete type applications, but that's a huge opportunity. Concrete's the most widely used material other than water in the world, and our infrastructure, all of our construction really hinges on it. So it's about 30 billion tons of concrete produced a year. It's a large starting point for us, Christine.
Okay, you've got a lot on your plate already. Russell, thank you so much for your time. Great talking to you. Thank you for sharing your technology with us.